Hello everyone, in this video we will introduce step number 5, how to program the PID function block PID Compact in the S7-1200 and 1500 PLC. In the previous videos, we introduced how we can set up the scale analog input and scale analog output program. Also, we set up the trend and the trace for monitoring the setpoint input and output of the PID. So in this video, we will introduce detailedly about this PID Compact PID function block. This is one typical PID control loop. The core function, the core PID algorithm that is in the PID underscore compact, this function block. And the feedback from the system that goes through this path. So the sensor sense the process and using the transmitter transfer to 0 to 10 volts or 4 to 20 milliamp, and using the analog input plus the analog input scale finally convert to a float value. This float value will be used as a process value feedback used as an input of this PID underscore compact. For the PID control signal that come from the output of this function block, this output command that is from 0 to 100, that is a 1% value. This value go to the analog output through the analog output Unscale program and go through the analog output channel. This analog output module output the 0 to 10 volts or 4 to 20 milliamp, control the actuators, and then control the process. This is one typical control loop. So in this video, we will mainly introduce the detailed setting and how we can program this PID underscore compact. As we introduced from the step 1, the first video, we already have one sample program. That sample program can be downloaded by this ID number from the Siemens support website. And the sample PID program that comes from the cyclic interrupt OB30. And if you open the OB30, in this OB30 is already programmed one sample program that is a PID compact here. And plus those tags already connect to this PID underscore compact. And this PID compact, all those tags already connect to this HMI. In this HMI, it has a lot of screens which are very useful. So plus this PID underscore compact, it can be used as a PID template. So I will now delete this existing function block. Instead, I will start from the scratch, set up a new function block PID compact, and show how can we start from the beginning. And let's click this properties. Because currently this programming language, this is FBD. I prefer to use the ladder logic. So let's select to the ladder logic. They can be transferred. So we will program the PID control loop under this cyclic interrupt 100 milliseconds OB30 and double click. Okay. So this is the existing PID. We can from here, just below this network, let's create a new network. So the PID underscore compact, this function block come from the technology here. Let's shrink this basic instruction, find out the technology, and under the PID control here. And there's one universal PID compact here. Let's drag here. And it will automatically generate one instant dB here. So usually we will rename this instant dB. For example, if this PID loop, we are controlling one temperature, so we can call that PID compact underscore temperature loop. Okay, so we can use the menu to rename this. For example, if the first loop that is 1130, we can call this that is 1131. So this is the initial status of this PID underscore compact. Because from a control loop wheel, the essential input and output of the PID, that is the setpoint, process feedback, input, and control output of this function block. To learn this control loop diagram of this function block, we can go to the help of this function block. Click this F1, and we can go to the description of this PID_compact. Look at the inside diagram of this PID algorithm. So firstly, the PID algorithm, that is this line, this equation. And then this is very important. This picture basically shows how this PID signal loop as a PID loop. Firstly, very important, that is a set point and feedback input, right? So firstly, the set point is here. And then the feedback that comes from these two channels. One is from the input, one comes from the input underscore PER. As we introduced from the previous videos, often we will use this input rather than this input underscore PER. That's because usually we will scale the input channel and transfer to the float value according to your process unit. And this process value will be used for alarm, compare, the multiple purpose. So we will scale the analog input offsets of PID function block and connect the converted value, the float value, to this input of the PID. And that input PER on, that is a switch between these two channels. By default, that will switch to the input, this channel. Other than the set point and the process value feedback, that is the input of the PID, the third important, that is the output of the PID. The output control signal will go to three channels here. Often, we will use the output only. That need you to program the Unscale program outside the PID. We introduced in the previous videos. And the second channel, that is the output underscore PER. So this channel includes the Unscale program, but most of the time we will program the Unscale outside the PID. And third channel, that is a PWM. If you are using the PWM controlling the motor or the fans of the DC motor, you could use this channel. But based on my experience, 95% project we will use the output only, so the first channel, and unscale the analog output outside the PID. Alright, other than the set point, input and output of the PID, another two important, that is a manual and auto mode switch. As we can see from this diagram, that state, this state value, when it's equal to 4, so the output will directly controlled by the manual value. So the PID control is under the manual control mode. So this manual value, that is a 0 to 100. If this state value equal to 3, so that means the system is under the auto mode. That algorithm will work for the auto control. So output will be controlled by the PID algorithm. That PID algorithm comes from this equation here. Using this state to change the manual and the auto mode in the S7-1200 and S7-1500 PLC, this is the key difference between the latency controller, that is S7-300 and 400. In the past, the latency controller 300 and 400, that PID will be only used one bool tag to switch the manual mode and auto mode. But for the new controller S7-1200 and 1500 controller in TIA Portal, the PID Compact will have a fine-tune mode other than the auto and the manual mode. So the Siemens uses the state to change the manual and auto mode. To check out the multiple states, we can go to the parameter state and the mode of this PID Compact. Firstly, 0, that means inactive. So with this state, we can shut down this PID control. Basically, we only use this state unless this PID loop got something wrong. Most of the case, we will use this state 3 and state 4. When this manual enable signal changed from 0 to on to true, the system will change to the state 4, manual mode. And when this manual enable change from true to false, there's a falling edge, the system will change to the state you set. For example, you can set the auto mode, or you can change to the fine-tune and pre-tune mode. That is number one. Number one, that is a pre-tuning, and number two, that is a fine-tuning. Till here, you might be very confused why the system designed like this, using the state number to switch the auto and the manual mode. But don't worry, I will clarify for you. So actually, the very important tag, that is this manual enable. To check out this manual enable function, from this table, if you search the manual enable, so you will find when the manual mode equal to true, that is under the manual mode. But it doesn't explain when the manual enable equal to false, what will be. In this table, it only introduces when the manual enable equal to true, the system will switch to the manual mode. However, if this manual enable equal to false, actually it doesn't introduce very clearly, especially for this automatic mode. To clarify this, please follow me. We need to check out the detailed description of this manual enable. That is in this input parameter of the PID Compact. So let's check out this manual enable. From this right side description, we can see when this rising edge actually works for switch to the manual mode. With this rising edge, the system will change the state equal to 4, switch the PID into the manual mode. In addition, as long as this manual mode enable signal change to true, so the system will not change the other mode. It will force the PID change to the manual mode. In the opposite, if this manual enable signal change from true to false, this falling edge, that will activate the operation mode that is specified by the mode. So what does it mean of this mode? Let's go to this in-out parameters of the PID Compact. So this mode that is associated with as the number, state number. So the mode 4, that is a manual mode. Mode 3, that is the automatic mode. Combine this description and the mode number, that means when this manual mode enable from 0 to on, with this rising edge, the PID loop will switch to the manual mode without any problem. When this manual enable switch from on to off, this falling edge, the system actually at that moment need to read the actual mode number. If that mode equal to number 3, so the system will switch to the automatic mode. Which means before you change the system from manual to auto mode, you can change this mode number to 3, get it ready, and then when the manual enable change from true to false, this falling edge, the system will use this mode number 3 to switch the system into auto mode. So a brief summary, to switch the PID from auto to manual mode, you can just direct set the manual enable to true, so the PID will switch to the manual mode. And switch the manual mode to auto mode, you need to prepare this mode number equal to 3, get it ready, and then use this manual enable the falling edge, or the mode active bit, turn it on, so the system will switch to the mode actual equal to 3, switch the PID into auto mode. This is the programming thread and the logic to handle the manual and the auto switch over. And also we need to take care of the bumpless between the auto and the manual switch over. We will discuss after. And other than this, keep in mind the current version we are talking about, that is a PID Compact version 2. So for the new firmware controller, S7-1200 and 1500 controller, for the TIA portal greater than version 50.1, so it's highly recommend we will use the PID Compact version 2, this is PID version. And you'd better read the detail of the description, because the version 1 Compact and the version 2 Compact, they are slightly different. So we better use the latest version, version 2, and a new firmware controller and the higher version TIA portal software. Alright, let's shift back to the PID programming. From the previous videos, we introduced how we can scale the analog input and how we can unscale the analog output. So we can connect that scaled analog input value into this input of the PID, process value feedback input, and connect the output, the control signal, to the unscaled analog output. Firstly, let me go to the analog input scale. Okay, that is the value from the analog input channel. Okay, I can copy and paste on this input. Okay, and analog output, the command that is this, analog output real source. So I will copy this tag, paste on this output of this PID. From a control loop view, as we can see, we connect the input, the analog feedback, and also we connect the analog output from the PID control. And next, that is a setpoint. So when the PID is working in automatic mode, the PID algorithm will compare the setpoint and the process feedback, the input, and use the error of these two values and calculate the PID control. So this setpoint unit, that is the same as the input value. And usually this variable will be connected to the HMI screen, and the operator can use the HMI set the value on this setpoint. And the PID will work in the automatic mode, compare the setpoint with the input of the process value input. And the manual enable, that is the one bool signal. So that means when this manual enable from 0 to 1, there's a rising edge. So this PID will switch to the manual mode. And when the system switch to the manual mode, this manual value will directly go to the output. So from here, we will connect one float value. That value is from 0 to 100. That is a manual control value for the output. And from here, this is that mode. And this mode is one integer value. So let's go to the tag, this DB, create one mode value. Let's open the DB, rename the tags. Let's create one tag. So we can call that is a PID mode. That is our integer value. Okay. I will drag this PID mode here. As we just discussed, when this mode equal to 4, the PID loop will ready to switch to the manual mode. And if it's equal to 4, the PID loop will ready to switch to auto mode. And this mode setting will be enabled right into the PID controller by using the mode active turn on, or this manual enable shift from true to false, that falling edge. Alright, so let me show how can we program the auto and the manual mode switch over. And I will use one network before this PID controller. So we will program. So we will add one. And let's drag a move command. We need to move number 3 equal to this mode. When this manual enable is a 0. So we need to reverse this logic. That means if you want to switch the PID from manual to auto, so you need to switch off this manual enable signal. This signal will change from on to off. With this off signal, we will write 3 to this mode. And in the next network, we will run the PID. So PID will use this falling edge, change this number 3 mode. Number 3 mode, that is automatic mode. Reversely, to switch from auto mode to manual mode, we need to switch this manual enable signal to on. So with this manual enable rising edge, the PID controller will switch to the manual mode directly without any additional programming. I leave the comments here so you can look at the detail of this description. Okay, Basically, we finish all the essential inputs and outputs of this PID Compact function block. Oh, sorry, I forgot this Setpoint. So let's put in the Setpoint tag. Okay, I will connect this tag. So Setpoint, feedback, and control. For the manual and auto, we will use this bool to switch the system in manual and auto. And when the system in manual mode, we will use this manual value that is from 0 to 100 directly control the output. And using this mode, that allows the system switch to the automatic mode. And other than this, there's also one error acknowledge and reset. It is value for us to program one bool on the error acknowledge and reset to reset or acknowledge the error when the PID loop go into a very special condition. Okay, we will connect the tag compact error acknowledge and connect one bool that is used to reset the error for this PID loop. It's also highly recommend we can connect one tag on the output of this state, so we can look at the actual state of the PID controller. For example, it's actually in the manual mode or automatic mode. When the state equal to 3, that means the system is in the manual mode. When the state equal to 4, that means the system in manual mode. So that is the state. Okay, that is one integer value. From here, we can see automatic means number 3, and manual, that means number 4. To monitor the error status of the PID controller or check out the error status, so we better connect one tag on this error and error bits. So this tag, that is one bool. It shows if this PID loop got something wrong here. So this error, that is one bool signal. And this error bits, that is the word here. Okay, those are the essential tags around this PID function block. Alright, that is the step 5, sub A, how to program the PID controller in the TIA portal using the PID Compact. In the next video, step 5, sub B, we will introduce how we can set the parameters, the gain, integral, and the derivative parameters in the PID controller. How we can find out where of those PID parameters. And other than this, we discussed we use the state, this value, integer value, to receive the status of the PID controller. In actual projects, we will need to use this state to program the manual mode and the automatic mode bumpless switch over. So we will discuss this switch over bumpless, this topic in the step 7. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.